Hello everyone, welcome back to the channel. I hope you guys are doing pretty well. So we will see today's daily challenge on Leetcode and we will try to solve it together. So let's see the problem. Sum of root to leaf binary numbers. So you are given the root of a binary tree where each node has either the value 0 or 1. Each root to leaf path represents a binary number starting with the most significant weight. For example, if the path is something like from root to leaf, if the path is 0 to 1, to 1 to 0 to 1, this represents the binary number 01101 in binary, which is 13. Okay, I hope you know how to convert from binary to decimal. And for all the leaves in the tree, consider the number represented by the path from the root to that leaf. Return the sum of these numbers. So you need to tell me that what are all the paths from the root to the leaf. Okay, so we can consider this tree as shown in the example. If this is 1, this is 0, this is 1, all the nodes of the tree must contain either 0 or 1. Okay, so yeah, consider this binary tree. So what you need to do is that you need to find all the path, okay, from root to leaf. So this is one of the path. Okay, so if this is one of the path, it will give you the number 100. Okay, 100 in binary, it means 4 in decimal, right? I hope you know that. And again, if you consider this path, it will give you 101. So 101 in binary will give you 5. Okay, and again it will give you 110, and 110 is nothing but 6. And again, if you just go through this 111, this another path, so it will give you 111 in binary, which is nothing but 7. So if we add all the numbers, it will be 4 plus 5 plus 6 plus 7, which is nothing but 15 plus 7, which is 22. Okay, so this will be your answer. And if you see in this example also, the answer is 22. I hope you do get what the problem wants actually. Okay, and there should be no problem in understanding this problem statement. Okay, I hope it is very clear. Now, one obvious method which will also be accepted, I guess, is that you can try out all possible ways using DFS and just calculate the number. Okay, calculate the number which you want. So what I want to say is that you can perform a DFS to find all possible ways. So perform DFS to find all paths. Okay, and convert all such paths to numbers. Okay, numbers in decimal, and you just add all of them. Okay, I hope you do understand what I mean to say, that when you are performing this DFS, you just keep concatenating in your string. So let's say this is 1, this is 0, this is 0, so you just keep concatenating. Okay, and you can also do something like return a vector of strings. So when you are at here, you are returning 0 and returning 1. Okay, so when you are this child, from the left child as well as the right child, you create a vector by concatenating this 0 to everything. So you get 0 0 and 0 1. Okay, and then again, when you are in this child, from the left child, if you concatenate 1 to all of them, you will get 100 and 101. In this way, let's say you get these numbers also, 110 and 111, and you convert all of them to decimal and just add the answer. Okay, but this is a brute force approach, and with a bit strict constraint, this might also give you a TLE. Okay, so we will not see this. Instead, we will see a very good trick. Okay, so to solve this, so what can we do? You see, if you see one thing, that what is the significance of each of the numbers. Okay, so if you try to see in this path, this number is 100. So it means that it is the most significant bit. Okay, so the root load is the most significant bit, and it will be nothing but, if you consider that, hey, in this level, everything which you will multiply by is 0. In this level, which everything which you will raise to the power 2 is 1, and here you will raise to the power 2 is 2. So it will be nothing but 1 into 2 to the power 2. But you may also get binary trees like this. Okay, so of varying depth. Okay, so one depth may not be the same as the other side's depth. So level order traversal, I will suggest you not to do in this problem. Okay, uh, yeah, but if you find a method of doing in level order traversal, that is also fine. uh, what we will do is that every time you see, what do, you can right shift your answer. So let's say this is your answer 1. You need to right shift these bits every time you go down. So uh, do you understand what I'm trying to say? This bit will be right shifted 2 times since you are going down. This bit of 1 will be right shifted only 1 time because you are going down by only 1 unit. Okay, so what do I mean to say is that see, 1, 1, 1, how do you calculate? So if you are seeing this path, how do you calculate? You see that you multiply 1 to the power 2 plus 1 to the 1 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, so this power is maximum when it is root node, and it is equivalent to saying that root node is left shifted 2 times. Root node 1, this one answer 1, is left shifted 1 time and 2 time. Okay, this node 1 is left shifted 1 time. Okay, so basically left shifted 2 times. Okay, this node is what? It is left shifted 1 time. Okay, I hope you do understand. And this is not left shifted anything, not shifted. Okay, so in this manner only you can just store all the answers and you can just have it. Okay, so what do I want to say is that for every path, so let's say you have a path starting from top to bottom. Okay, and the numbers which you get are something like this: 1 0 1 1 0. Okay, so let's say you get the number 1 0 1 1 0. Okay, now what is this number actually? So let's see, let's calculate and see how we will get through the answer. So it's 0 1 2 3 4. So it's 2 to the power 4 plus 2 to the power 2 plus 2 to the power 1, which is nothing but 16 plus 4 plus 1, which is 21. Okay, suppose you want to get this number in your path from root node to leaf node. Okay, suppose this is one of your path. Okay, just one of your path, and you are doing a DFS traversal. So what will you do in this case is that every time you can just right shift it. Right shift by 1, it also means multiply by 2. I hope you know this. Okay, right shift by 1 is also meaning that multiply by 2. So when you get this answer, your store answer is 1. So when you go down, you just right shift by 1. It means that multiply by 2. So you do answer equals to answer plus 2 plus this 0. Okay, plus this 0, which will be nothing but answer equals to 2. Now since you are again right shifting, okay, again going down means again multiplying by 2, you do answer equals to 2 into 2, this answer into 2 plus 1. Okay, plus this answer 1, which will give you nothing but 5. Okay, now again when you go down, uh, what you do? You do 5 into 2. Okay, and okay, so this will be 2, right? You see, I did a mistake over here. This will be 2. So this will be nothing but 5 into 2. Again, this answer into 2 plus 1, it will be 11, right? And if you just go down, this will be answer equal to answer into 2, which will be nothing but 11 into 2, 22. Okay, so the thing is that when you move down, just multiply answer by 2. I just multiply answer into 2 plus the root arrow value. Okay, plus the current node arrow value. Okay, this is this thing if you keep on doing, and you will get your answer easily. I hope you do understand from answer 1 how you just right shift by 1, that means multiply by 2, and then you do it in this way. Similarly, for all the paths you can get it in this way, and you can just add your left answer and your right answer to your final answer. Okay, so I hope this will be very clear when I code that out, what I want to say. So you can just return another helper function which will give you root and your answer, which is initially 0. Okay, So you want to return your answer. So when you have this helper function, you can just write tree node star root and int answer. Okay. So if you encounter your root to be null, so what you can do, you can simply return 0. Okay. And what I want to say is that answer will be always answer into 2 plus root arrow val. I hope this thing is very much clear through our approach. Yeah, this approach came by just thinking that every bit from the root will be right shifted most number of times. So the level includes how many number of times you need to right shift that bit. Okay. So yeah, right shift means multiply by 2. You just multiplying the answer by 2 and adding the root arrow well. Okay. And I hope after this, what you need to do is that see, when you reach a leaf node, okay, so if your current node is a leaf node, so you have already completed your traversal from root to leaf. Okay, if your current node is a leaf node, you have completed your traversal from root to leaf, and you can simply return the answer. Do not need to do anything after calculating, just return the answer. Do not return 0. So if it is a leaf node, then return the answer. So if root arrow left is equals to null, so for the leaf node, the root arrow left and left subtree and the right subtree both are null, right? So if both are null, it means that you have reached the leaf node, then return answer. So it means that reached leaf node. In other words, you have also reached the destination. Okay. So and you can, for this you can just simply return your answer, not the final answer. You see, you calculate your values from the left subtree and the right subtree and then add both of them. Okay, so you can just see left and helper of uh, root arrow right answer. Okay, so you can just simply return all the answers from the left subtree and the right subtree, and yeah, if you just submit this, I hope this will work just fine. Yeah, this much code is only there. I hope if you do understand the solution, the coding portion is very easy for this. And yeah, that's all. That's all. You get a decent runtime as well as memory. So yeah, that's all for this video. I will meet you in the next video. Till then, thanks a lot.